We saw in the first video that the function f of x equals x squared does not have an inverse. And here we were just thinking about it sort of informally as, is that something I could undo? If I know what the result is, do I know what I plugged in so that I can get back to that result? And we said, no, it's not. I want to just take a look at our new method for finding a formula for the inverse function to explore a little bit more what actually goes wrong there. So if I were to rewrite this as just y equals x squared and say that's the original, I would switch the roles of x and y. So I would get x equals y squared, and that would describe the inverse. Now, that does describe an inverse relation. Remember, a relation is just a set of ordered pairs. All the ordered pairs that make that equation true are part of that relation. The question is it a function? And if it's a function, there has to be a unique y value. Okay. So I would go to try to solve for y. So I would take the square root of both sides. And I would say, oh dear, nope, this isn't going to work, because that would give me the absolute value of y. And there are two numbers there are two numbers that would have any given absolute value. If x was, let's just say 4, okay, then the square root of 4 would be 2. I'd have the absolute value of y is 2. Y would be plus or minus 2. So I would not get a unique answer. So we can't solve uniquely for y. And so we say f is not invertible. That doesn't mean we can't switch the roles of x and y to get a relation, but we can't switch the roles of x and y to get a function. Okay. All right. So I'm going to just put up a couple of problems for you to try. Let's let h of x equal 1 over x plus 2. I want you to find a formula for the inverse, or explain to me why the inverse doesn't exist, if that's the case. And then I'm also going to give you a function this way. Remember, a function is just a set of ordered pairs, so that each x has a unique y. So let's say we had 1, negative 5, 3, 0, 4, negative 2. So that's also a function. I want you to find the inverse function. So find me a formula for the inverse function here, and find me the inverse function here. You'll be giving that in the same format as just a set of ordered pairs. So pause the video and try those two. I'm going to answer this second question first, just because that way I can clear the board space and then I've got the whole board to work with. Okay. We said that with inverse functions, we're just switching the roles of x and y. So I'm literally going to do that 1 point at a time for each of these 3 points. So 1, negative 5 becomes negative 5, 1. 3, 0 becomes 0, 3. 4, negative 2 becomes negative 2, 4. That's what inverse functions do. So I can think of them as undoing whatever the function does. I can also think of them as just switching the role of the input and the output, or switching the role of the x and y values. Okay, so let's try h of x. I'm going to go ahead and just write that using y's and x's as y equals 1 over x plus 2, and label that that's the original function. Now if I switch the roles of x and y, I'll have x equals 1 over y plus 2, and that's the inverse. And then to get the y's out of the denominator, I'm going to multiply both sides by a y plus 2. So I'll have x times y plus 2 equals 1. Now I do have this restriction that y is not equal to negative 2, because that would have made the denominator 0. Again, if I'm able to uniquely solve for y, that restriction is going to take care of itself. It's going to turn out that I get a formula that's never going to give me a negative 2. So I'm not going to strictly require that you record that, but I'd suggest it as just a good habit because there are times when recording those restrictions does become necessary. So might as well write it even when I'm not requiring it so that you don't forget when I am. All right, now I want to try to solve for y. That means I'm going to have to break it out of those parentheses. I'll do that by distributing the x. So we'll get xy plus 2x equals 1. Now, to solve for y, I can say xy equals 1 minus 2x. To get y by itself, I would now divide by x. So y is going to equal 1 minus 2x all over x. That's going to be a formula for my reciprocal function. I'll just point out, I could write that another way. If I wanted to, I could distribute this division. So that would be 1 over x minus 2x over x. Here I could cancel those x's. So I'd have 1 over x minus 2. No need to record here that x can't be 0 because I can see that from the fact that it's in the denominator of this term. One thing that's nice about this is I can see now that that's never going to spit out a y value of negative 2. Not super obvious in this format, but here the only way this could give me negative 2 would be if 1 over x was 0. But that's not possible because a fraction is only 0 if the top is 0, and the top of that fraction is 1. The other thing that's kind of nice about this is I might have felt comfortable doing this one by inspection. I can see what h of x has me do is first of all add 2 and then take the reciprocal. So h inverse, oh, sorry, I forgot to do that. My goodness. H inverse of x would be 1 minus 2x over x, or equivalently h inverse of x is 1 over x minus 2. I did want to write my answer using function notation, so I apologize for initially skipping that step. Okay, h inverse, if I want to do the opposite things in the opposite order, well, the opposite of taking the reciprocal is actually taking the reciprocal. Taking the reciprocal twice undoes taking the reciprocal. So I would take the reciprocal, and then to undo adding 2, I would subtract 2. Notice that's exactly what this form gives us. We took the reciprocal, and then we subtracted 2. Okay. I do recommend that you know how to find the inverse by writing things in terms of x's and y's, and then switching x and y and solving for the new y. The example that we did last time was not one that you could do by inspection because the formula was complicated enough that it was really difficult to see what things we were doing in order to just switch the order. If you did want to do this by saying, I'm going to just look at this and say I need to do the opposite things in the opposite order, I would want you to show some work. So simply writing down, this is what h does, so this is what I'll do to reverse that process, that would be sufficient. But don't just go to the answer. Do show some work to justify your answers always.